Hello, we will be covering combining functions in this video. Take notes. Message me during the viewing of this video if you have any questions. 2.7 Combining functions. So what we're going to be doing here is we're going to be looking at combining functions, which means like how do we add two functions together? How do we subtract them? How do we multiply two functions? And how do we divide? And then we are also going to take a look at how do we do function composition. Okay, so algebra of functions. Okay, so we're going to go ahead and let f and g be functions. So let f and g be functions with domains a and b. Then the function operations are defined as follows. All right, so number one, we have addition between functions. So if I want to add f plus g of x, that's equivalent to taking f and adding it with g, okay? And then the domain here will be the intersection of A and B. So the intersection is just those values that they have in common, okay? So like if A is made up of all real numbers and then B is made up of all real numbers except 0, then your domain is all real numbers except 0 because they have everything in common except for 0, okay? All right, and then we also have subtraction between functions, f minus g of x, and that is the same as doing f of x minus your g function. And your domain here is also the intersection of a and b. And then we have multiplication and division coming up here. So we have f times g of x, and that's the equivalent of multiplying your f function times your g function. And your domain here is also the intersection of a and b. And then for division, f divided by g is the same as saying f of x divided by g of x. And your domain here is, yes, it's a intersected with b, but since we have a fraction here, you need to make sure that you exclude any values that make g of x, the denominator, 0. Okay, so domain is going to be a intersection with b such that g of x is not 0. Okay, all right, because then we get undefined. All right, so let's go ahead and take a look. So here's an example. of having two functions. So let's let f of x equal 1 over x minus 2. And let's let g of x be the square root of x. Okay? And so here, the domain of f, I'll put a little f there. The domain of f is all real numbers except 2, right? So because we know that x minus 2 cannot be 0, so x cannot be 2, okay? And if I put that on a number line, x cannot equal 2. So here, let's pretend that's 0, 1, 2. Okay, so here's 2. So x cannot be 2. However, it can be everything else, right? So this here that I'm doing represents the domain of f. Let's take a look at the domain of g. I'll put a little g here. The domain of g, well, we know that whatever's inside this square root, which is x, has to be greater than or equal to 0. So that's our domain. All x values greater than or equal to 0. So when I graph this, then I have here is 0. So starting from there and everything this way, right? So we see here the intersection of A and B is this part right over here, all of this here, except 2. Okay, so I'm going to go ahead and write this in interval notation. So our A intersection with B is from 0 to 2, parentheses, and then 2 to positive infinity. Okay. All right, so let's take a look at doing those operations: addition, subtraction, multiplication, division between two functions. Okay, so let's go ahead. We'll do 2 parts. So using the same functions, these up here, f and g. So let's do part 1. Here, I'll write f and g again so that we can scroll. Do the following operations using f of x and g of x above. Okay, so 1 over x minus 2. Here, I'll just write it again. 1 over x minus 2. And g of x is square root x. Okay. All right, so number 1. Let's go ahead and do f plus g. Okay, so f plus g is 1 over x minus 2. That's f. Plus g. G is square root x. And there are no like terms. And so the domain here is the intersection of their domains, which will be this. Okay. So 0, 2, union 2 to positive infinity. Okay, and then f minus g is going to be 1 over x minus 2. That's f minus g, and g is square root x. And again, the domain here is the intersection of their domains. You can think of it as all real numbers except for whatever is not allowed here and not allowed here. Okay. All right. And number 3, f times g, multiplication here. So that would be f, which is 1 over x minus 2, times square root x. Okay. Let's just simplify that a little more. Let's clean it up. So that would just be square root x over x minus 2. Okay. And the domain here would be the intersection. Oh, you know what? Why am I writing union? Oh, duh, because that's the intersection. Okay. All right, okay. And then number 4, f divided by g. So this is going to be 1 over x minus 2. Division, we can use this fraction. We can use the division symbol. Okay, so I'm just going to use this one so that we don't have so much vertical space. Okay, so I have this. And if you recall, when you have division of fractions, you do multiplication by the reciprocal, which will be 1 over square root x. And so that's just going to give me 1 over square root x. I'll put that on the outside because I can. Okay, so I have this, and the domain here will be, now in this case, so here we had said that your domain, when you do the division here, the domain is the intersection such that g of x is not 0. So we don't want 0 in the denominator. So let's see what other values we need to exclude. Okay, so over here, we have to exclude 2, and that's why we have it written like this. All real numbers except for 2. Okay, but we also have to exclude 0. Okay, so we have to exclude 0. So here we see we have a bracket on 0, right? But now we cannot have the bracket on 0 because if x equals 0, we get undefined right here. Okay, right here. All right, so we're going to go ahead and use a parenthesis instead. Okay. So 0, 2, union to positive infinity. Okay. All right. So that's how you do your operations. Pretty straightforward, especially with these two functions here, because they don't have any like terms, so there really wasn't any combining of terms. Okay. All right, but let's take a look at part 2, where we do operations with these two functions, and we also evaluate. Okay, so part 1, we just looked at how to add and subtract them and find the domain. Part 2, we are going to, again, use the above functions for f and g. So these guys again. Okay. And then we're going to evaluate. Okay, so let me go ahead and write them here again. 1 over x minus 2. And g of x is square root of x. Okay. All right, so let's take a look here. Suppose that I have this to evaluate. F plus G of 4. Okay, so a couple ways you can go about this. So you can do F of 4 and you can do G of 4 and then combine them. So if I do F of 4, that's 1 over 4 minus 2. If I do G of 4, that's square root of 4. And then I can work this out. 1 over 2 plus 2, and that's 2.5, 2.5. Okay? Or I can do F plus G of 4, where I first do the adding of the functions, okay, and then evaluate. Okay, so I could do it like this. So I could do the addition of the functions first, which is going to be 1 over x minus 2 plus square root of x. Nothing exciting there. So you could do that first and then evaluate it at 4 and then plug that in. Okay. And here you might be like, okay, I don't really see the difference. Okay, so here, this one, you don't really see the difference because these functions are so different from each other that there was no combining of like terms. But if you had something like this, f of x equals 2x squared plus 3x, and you have g of x is another polynomial, like let's say you had 4x minus 1, right? Well, this becomes a little more interesting as far as which method you use, okay? Um, because what happens is you could do it this way, where I would plug in 4 here and work it out, plug in 4 here, work it out, and then add them, right? That's what we would be doing if we use this method. Or I could use this method where before I plug in the 4, I actually add these together and I get this new function, right? So I could add these two functions together. And then once I simplify that, then I can go ahead and plug in the 4. Okay, so, but like I said here, there really isn't anything you can do between the two functions. So these two methods look very similar. Okay, let's do letter B, F minus G of 4. Okay, so that's going to be 1 over 4 minus 2 minus square root of 4. 4 minus 2 is 2. Square root of 4 is 2. And this here will give us negative 1.5. Okay. And letter C, F times G of 4. So F times G, we already know what F times G is. That is up here. F times G is square root x over x minus 2. Or if you want to just split them up, you can split them up and do one at a time. So you could do this as well. 1 over 4 minus 2 times the square root of 4. And you would get this, which equals 1. Okay. Letter D, let's do F divided by G evaluated at 4. All right, so that would be 1 over 4 minus 2 divided by the square root of 4. So that would be 1 over 2 divided by 2, which is 1 over 2 times the reciprocal, and we get 1 over 4. Okay. All right, so that's how you work with the operations with functions. Pretty straightforward. So the topic here that's a little more abstract is the composition of functions. All right, so given two functions f and g, the composition function f circle g, and that's pretty much how we read it, f circle g, is defined by this. So if you get f circle g, that essentially means f of g of x. So you would basically be evaluating f at g of x. So in other words, if you have some function f, the thing you replace the x with is going to be g of x. Okay? All right. If you're like, what? Just wait till I do an actual example and you'll see what I mean. Okay, and then the domain so here, when you're finding the domain here of this composition function, you can think of it as all the x in the domain of g and in the domain of f circle g. Okay, so let's take a look. Go ahead and write this down. So the domain is going to be all x in domain of g and in, and I'm just going to put this in quotes, and in the domain of f circle g. Okay, so i.e., if the domain of g is a and the domain, and I'll say this loosely, the domain of f circle g is b, then the actual domain of f circle g is the intersection of a and b. Okay? When we do a composition, you'll see what I mean. So what's happening here is you do this composition, and when you do this composition, you end up with a new function. And you might be looking at that function and going, oh, okay, well, the domain is all real numbers except for 0. Well, not quite. That might be true if that was if that was a standalone function, it wasn't from the composition of a function, fine. But because it comes from the composition of a function, then you have to take this function that we're plugging in. We need to take that function into account when we figure out the domain. So if you end up getting this new function when you do this composition and you're like, oh, the domain of this new function is all real numbers except for 0, you also have to say all real numbers except for 0, and you also have to exclude anything that is outside of G's domain. Okay? So fine if you get all real numbers except for 0. Great. But then if 2 is not in the domain here, if you knew that from the start, you also have to say, oh, all real numbers except 0 and 2. Okay? So you have to get your domain of F circle G and exclude anything that does not work for G. Okay? All right, so let's take a look. Kind of abstract, I know. All right. Let f of x equal x squared and g of x equal x minus 3. A. Find f circle G and its domain. Okay, so f circle G. All right, so f circle G is essentially f, and we're going to plug G in to the f function. Okay, so here, off to the side over here. If I said f of 3, you don't have to copy this down. So if I said f of 3, this means you would take this value 3 and substitute it in for x in this f function, right? If I said g of 3, then you would take 3 and you would plug it into this function here, right? Okay, so if I said f of, let's say f of m, then this means you would take this m and substitute it into this function over here, m squared, right? If I said g of n, then you would take that n and you would plug it in here and you would get n minus 3, right? Okay, so here, this is saying take whatever g is and plug it in there. Okay, just like if it says 3, you would substitute 3 into this function. If it says m, you would substitute m into this function. If you have another function, you would have to plug in that actual function over here. So let's take a look. All right, so let's go back over here. So f of g means f of x minus 3. And so this is what I need to substitute into the f function. Okay, so I will replace the x over here with g, which happens to be x minus 3. So I'm going to replace the x with x minus 3. And I get x minus 3 squared. Okay, so this is my composition function, x minus 3 squared. And the domain, so here, x minus 3 quantity squared, there's no restriction, right? It's not a fraction. We don't have x in the denominator, so we're good. We don't have it under a square root. We're good. So here, the domain here is all real numbers. All real numbers. And if I look at g is x minus 3. Do I need to exclude anything? No. Okay, so then my domain stays stays all real numbers. Okay, had it been that, and my domain is all real numbers except 3, and then like I end up with something where there are no restrictions, right? Then I would have to say, oh, except for 3, all real numbers except for 3. If there are going to be any restrictions here, you need to include them here. If there are any restrictions here, you need to also include it here. Okay, it's always the function that you are plugging in. That's the one you need to look at. Okay. All right, let's take a look at another example. B. Let's go ahead and find G circle F and the domain. Okay, so G circle F is the same as G of f of x. What is f of x? F of x is x squared. So it's like saying find G of x squared. So x squared is going to be the one that we plug into the G function. So let's see. Here's the G function. I'm going to substitute x squared in for x. So I get x squared minus 3. There are no restrictions here. So my domain is going to be all real numbers. And then let's double check to see if there are any restrictions in this function that we plugged in. And we see up here that the function is x squared. There are no restrictions. So this still remains our domain. Okay. If there were any restrictions, we would have to state them here as part of our domain. Okay. Letter C. Let's go ahead and find F circle G of 5. So this is an evaluation kind of problem. So this is taking your composition function f circle G and then evaluating it at 5. Okay, so let's take a look. We already know what f circle G is because we did it up here. F circle G is this right here. So f circle G is x minus 3 squared. Okay, so that's our composition function. And now we have to, this says we have to evaluate this function for x equals 5. Okay, so f circle G of 5 means to substitute 5 in for x. So that's 5 minus 3 squared. 5 minus 3 is 2. 2 squared is 4. Okay. And let's do letter D. Go ahead and find G circle F and evaluate it for x equals 7. Okay, so go ahead and hit the pause button and see if you can do this one. Okay, so G circle F is, let's scroll back up here, x squared minus 3. G of F is x squared minus 3. So then G circle F evaluated at x equals 7 is going to be 7 squared minus 3, which is 49 minus 3, which is 46. Okay, so you should have gotten 46. All right, let's go ahead and do this with different other functions. Okay, so let's use f of x equals square root x. G of x equals square root of 2 minus x. So these are going to be a little more interesting because here we do have restrictions on the domains. So depending on the the function composition that we're doing, we might have to make adjustments to the final domain. Okay. All right. So let's do the domain of this one so we have it ready. And let's do the domain of this one so we have that one ready. All right. So the domain here, I'll just write D and I'll put a little subscript F. Okay. So the domain of the F function, we already know X has to be greater than or equal to 0. Okay. So here, X has to be greater than or equal to 0, or another way to write that is like this. And then over here, your domain of G, I'll write it like that. We know that 2 minus X has to be greater than or equal to 0. So 2 has to be greater than or equal to X. So X is less than or equal to 2. Okay, so this is our domain. Okay, so that's going to be interesting. Let's see. A. Let's find F circle G and the domain. All right, so F circle G means F of G. What is G? F of square root 2 minus X. So that's what we're going to substitute into the F function. So square root of the square root of 2 minus X. And this here is the same thing as saying the fourth root of 2 minus X. And we do have a restriction here. We do know that 2 minus X needs to be greater than or equal to 0. So 2 has to be greater than or equal to X. All right, so so far this is our current domain of the composition. We did substitute G into this function. So we need to take a look at G's domain as well and exclude anything that G is excluding. So let's take a look. X is less than or equal to 2. Well, that's what we have here as well. So there's nothing to add to this. So our domain here, final domain, is negative infinity to 2. Okay. All right, let's try this one. Letter B, G circle F, and the domain. All right, so G circle F means G of F. What is F? Square root of X. Okay, square root of X. So G of square root X, that's what we're substituting into the G function. So we get square root of 2 minus the square root of X. Okay. All right, so what's our domain? All right, so we know that the inside needs to be greater than or equal to 0. So 2 has to be greater than or equal to square root X. Square both sides, and we get 4 has to be greater than or equal to X. Okay, so far this is our current domain. X has to be less than or equal to 4. Now let's take a look at this here. What is the domain of F? Scrolling all the way up. Greater than or equal to 0. Okay, so let's go ahead and compare those two. So greater than or equal to 0. All right, so this one is saying, okay, current domain is greater than or equal to 4. So here's 4. And it looks like this, right? Greater than or equal to 4. the f function, that's the one that's inside here, so that's the one we need to look at. And we said the domain of the f function is x is greater than or equal to 0. So x is greater than or equal to 0. Oh, here, this one's actually not correct. This is x is less than equal to 4. So that's this way. And x is greater than equal to 0. 0 is right around here. Okay. 4 is over here, right? And x is greater than or equal to 0. So this is what it's looking like, right? So here we need to do the intersection. We need to do the intersection, what they have in common. Okay, what they have in common is the domain, is the final domain. So what do they have in common? Well, it looks like, here, let me get a different color. What they have in common looks like starting from here, 0 to 4. That's the only stuff that they have in common, 0 to 4. Okay, so that's going to be our domain. Our final domain is 0 to 4. Okay, so that's why you have to be careful. You can't just take the domain of this final function right here. You have to take the domain of this final function combined with this one, because this is the one that we plugged in over here. Okay, so it's the final function together with this one. Okay. All right, let's take a look at this next one, letter C. Let's do F circle F and the domain. Okay. All right, so F circle F means f of f. So we are going to plug in square root x into the f function. So that's going to give me the square root of the square root of x, which is the fourth root of x. Okay. So here, the domain of this fourth root of x, we know is x has to be greater than or equal to 0. Okay. And then we have to look at the domain of this inside function. And we already know that it has to be greater than or equal to 0. So this one remains our domain. Nothing to add to this. Okay. Or really subtract, huh? Okay. Let's take a look at G circle G and the domain. All right, G circle G means G of G, which means G of, what was the, I don't remember the function, 2 minus, square root 2 minus x. Okay. Square root 2 minus x. So this is going to be square root of 2 minus the square root of 2 minus x. Okay. All right, so let's figure out the domain of this composition here. So we know that the inside, 2 minus x, we know that this has to be greater than or equal to 0. So I'm going to go ahead and add the square root of 2 minus x to both sides. Cancel that. So I get 2 is greater than or equal to square root 2 minus x. Now I'm going to go ahead and square both sides. Square this, square this. So I get 4 is greater than or equal to 2 minus x. Okay. And I'm going to go ahead and move the x over here. So I get x plus 4 greater than or equal to 2, subtract 4, and x is greater than or equal to negative 2. Okay, x is greater than or equal to negative 2. All right, so that's my current domain, but again, I have to check over here and see if I need to exclude any values based on this function. All right, so I have x is greater than or equal to negative 2, and we know, here's the g function, x is less than or equal to positive 2. All right, so let's go ahead and take a look at those two together. We're going to have to do this and look to see what they have in common. Okay, so we have x is greater than or equal to negative 2. That's all of that. I'll do it on the same number line, purple. And then the domain of G was x is less than or equal to 2. So here's 2. So then that would be this. And we see that what they have in common, the intersection, would be this right here. Those are the ones that they have in common. So the domain, final domain, would be all x values from negative 2 to positive 2. Okay. All right. So that is it. If you have any questions, which, I anticipate you will, because domain is a pretty abstract concept for students, make sure you email me or text message me, or don't forget to take full advantage of our classroom tutor, who is available on Mondays, I think, and Wednesdays from 9 to 2, I believe. It's on the Canvas homepage for this class. All right, I will see you next time.